On November 16th, 1974, astronomer Frank Drake aimed the Arecibo radio telescope at a star cluster 25,000 light-years away and broadcast humanity's first interstellar postcard. A binary greeting. We exist. Here's our DNA. Here's our address. He thought we were saying hello. A growing number of physicists now think we signed a death warrant. The popular pitch is that finding alien life would be the greatest moment in human history. A cosmic awakening. Proof we are not alone. The reality, taken seriously by Stephen Hawking and a generation of astrophysicists, is the opposite. The galaxy may be silent for a strategic reason, not loneliness. By the end of this, you'll understand why the smartest civilizations are likely the quietest ones, and why we may have already failed the test. Reason 1. The universe doesn't run on trust. The argument is called the dark forest hypothesis, formalized by Chinese science fiction author Liu Cixin, a computer engineer by training, in his 2008 novel of the same name. Strip away the fictional packaging, and what remains is a piece of cold game theory that astrobiologists and physicists have spent the last decade taking seriously. Picture yourself in a forest at night. You can hear something moving. You don't know if it's a deer, a hunter, or a child. You don't know if it's armed. You don't know its intentions. You have a flashlight. The question is whether to turn it on. Most people would say yes. Most people are wrong. There are 3 things you cannot know about whatever is out there: what they want, what they are capable of, how those capabilities will grow. And in a universe of finite matter, finite energy, and finite habitable real estate, those unknowns are not just uncomfortable, they are fatal. Liu Cixin compressed this into 2 axioms. Survival is the primary need of any civilization. Civilizations grow continuously, but the universe's resources do not. From those 2 assumptions, a chain of suspicion unfolds. You cannot know if the other civilization is hostile. They cannot know if you are. You both know that the other might be, and might be capable of destroying you. You both know that whoever strikes first wins, and you both know the other knows this too. There is no stable equilibrium, and you both stay quiet and trust each other. There is only one rational strategy. Detect first, strike first, ask never. This is not conspiracy theorizing. It is the logical extension of a problem Cold War strategists wrestled with for 40 years, except this version has no hotlines, no embassies, no shared borders. The other side may be 1,000 light years away. Your warning of their attack will arrive 1,000 years after the projectile does. There is no negotiation. There is only the silence before impact. So when CT optimists imagine a benevolent galactic federation greeting our technological adolescence with open arms, the dark forest model asks one quiet question. What would such a federation actually do with a species whose first instinct on inheriting Earth was to industrialize, nuclearize, and start broadcasting its address to anyone who might be listening? It might not greet us at all. It might do something simpler, and the math says we wouldn't see it coming. Reason 2. The math of detection is brutally one-sided. To understand why this matters now, not in some far future thought experiment, look at the asymmetry of detection itself. Radio waves obey a law every physics undergraduate learns in their first month, the inverse square law. Double the distance from the source, and the signal weakens by a factor of 4. Triple it, and it weakens by 9. By the time the standard radio leakage from your microwave or your local talk station reaches Alpha Centauri, 4.3 light-years away, it has decayed into a whisper indistinguishable from cosmic background noise. Most of what we accidentally leak, the I Love Lucy reruns, the Cold War radar pulses, the cell tower static, never makes it past our solar system in any detectable form. That is the comforting part. Here is the uncomfortable part. Intentional broadcasts behave differently. Drake's 1974 Arecibo transmission used a 1 megawatt transmitter focused into a tight beam, boosting its effective radiated power to roughly 20 trillion watts in the direction it pointed. That signal is detectable, in principle, across tens of thousands of light years by anyone with a radio telescope larger than ours. And Arecibo wasn't alone. Between 1999 and 2008, a series of cosmic calls was beamed at multiple nearby stars from the RT-70 dish in Ukraine. In October 2017, METI International transmitted a message toward Luyten's star, just 12.4 light-years away. The signal arrives in 2029. A response, if any, in 2041. We didn't whisper, we yelled into the dark. Here is where the physics gets uncomfortable. Detecting a civilization is dramatically easier than reaching it, but reaching it is dramatically easier than communicating with it. A passive listener with a sensitive enough antenna, say the 500-meter aperture spherical telescope in southern China, fully operational since 2020, can pick up directional broadcasts at distances of thousands of light years. To respond requires similar transmitter power and a confirmed target. To attack requires neither dialogue nor diplomacy, just trajectory. Astronomer and physicist David Brin, who has been arguing against intentional broadcasts since the 1980s, frames it this way. In any encounter between two civilizations of differing capability, the technologically superior one decides the terms. Always, without exception in human history, and in galactic terms, superior doesn't mean by a few decades, it can mean by 1,000,000 years. Imagine a Roman legionnaire meeting a modern infantry platoon. Now multiply that gap by 10,000. That is the kind of asymmetry the dark forest assumes, and the kind we'd have no way to recognize until the consequences arrived. Our broadcasts can be heard. Our defenses cannot match what hears them. Reason 3. The scientists quietly trying to stop the broadcasts. This isn't a fringe idea kept alive by science fiction novelists. There has been an active, increasingly bitter argument inside the CT community for over a decade, and the people raising the alarm are not cranks. In 2010, Stephen Hawking made the warning explicit on camera. In his Discovery Channel documentary, Into the Universe, he compared a visit from advanced aliens to Columbus arriving in the Americas, pointing out that the encounter did not turn out particularly well for the Native Americans. He suggested any species capable of crossing interstellar space would be far beyond us and would have every reason to view us as a resource, not as peers. In February 2015, after a SETI Institute meeting on whether to begin actively transmitting messages, a coalition of scientists, technologists and researchers, including SETI veterans, astrophysicists, and Liu Cixin himself, signed an open statement urging caution. Their argument was simple. Broadcasting our existence is a decision that affects every human alive and the entire future of the species, and should not be made unilaterally by a handful of astronomers with access to a transmitter. The statement was largely ignored. Active SETI, also called METI for Messaging Extraterrestrial Intelligence, continues. Yuri Milner's breakthrough initiatives, launched in 2015 with $100 million in funding, includes a breakthrough message project specifically designed to develop transmissions to send. China's FAST telescope is technically capable of detecting weak alien signals from across the galaxy. The capacity to listen has never been greater. The capacity to keep our mouths shut, on the other hand, has never been weaker. In a 2014 paper in the Journal of the British Interplanetary Society, Brin called METI an existential gamble being conducted without informed consent of humanity, without scientific consensus, and without serious effort to consult the rest of the species these astronomers are speaking on behalf of. He argued that the scientists pushing METI cannot prove the universe is empty. They are simply assuming it. That is the assumption the dark forest hypothesis breaks. Not by proving aliens are hostile, by pointing out that we have been operating on a default of friendliness without a single piece of evidence to support it. The papers laying this out exist. They get published. They sit in academic journals. They don't get TED Talks. They don't get rebroadcast in the trailer for the next big space movie. They are inconvenient, and so they are quietly drowned out by the much more marketable narrative that meeting our cosmic neighbours will be the moment humanity grows up. It might be the moment humanity ends. Reason 4. The cheapest weapon in the galaxy is a rock. Suppose then that some civilization out there has heard us. Suppose they have decided, for reasons of pure game theory, that an unknown technological species is too dangerous to leave alive. What does an attack actually look like? Not laser ships, not invasion fleets, not anything Hollywood would film. It looks like a rock. The most efficient weapon in any universe governed by relativity is a relativistic kinetic kill vehicle, a piece of inert matter, a chunk of nickel-iron asteroid, for instance, accelerated to a significant fraction of the speed of light and aimed at your planet. The physics is brutally simple. Kinetic energy at relativistic speeds is governed by the equation E equals gamma minus 1 times mass times the speed of light squared, where gamma is the Lorentz factor. As you approach the speed of light, that factor explodes. Here is what that means in concrete terms. A 10-kilogram object, the weight of a small dog, accelerated to 99% of the speed of light, delivers on impact roughly 1.3 gigatons of energy. That is approximately 26 times the yield of the Tsar bomber, the largest nuclear weapon ever detonated by humans. And no fission, no fusion, no warhead is required. Just speed. A larger projectile, say a 100-meter rock, the size of a small office building, would, at relativistic velocity, end the surface biosphere of any Earth-like planet without ceremony. No warning shot, no demands, no incoming signal. Because the rock is travelling at 99% the speed of light, the light reflecting off it that might warn the target arrives only fractionally ahead of the projectile itself. By the time you see it coming, you have minutes, maybe seconds. A civilization 1,000 light years away that decided in the year 1024 to deal with the noisy newcomers on Earth could have launched its weapon then. Light from our 1974 broadcast won't even reach them until the year 2974. And yet, if they had any prior reason to mark our solar system as a candidate for sterilization, the projectile is already in flight. Silent, undetectable, decided. We have no defenses against this. None. Our planetary defense apparatus is calibrated for asteroids moving at human-scale velocities, kilometers per second, not hundreds of thousands of kilometers per second. The energy budget required to deflect a relativistic projectile would exceed the entire output of human civilization for decades, and we would need to do it in the seconds between detection and impact, which is to say, we wouldn't. The lights would simply go out. Reason 5. The silence is telling you something. Look up at the night sky. You're looking at roughly 100 billion stars in our galaxy alone, and somewhere between 100 billion and 2 trillion galaxies in the observable universe. Conservative estimates from the Drake equation, run with even modestly optimistic assumptions, suggest there should be thousands of communicating civilizations within our galaxy. We have heard from none of them. This silence has a name. Astronomers call it the Great Silence. For decades, the standard response was that we just hadn't looked hard enough, or long enough, or with the right instruments. As of 2026, we have now looked very hard, with very sensitive instruments for a long time. Breakthrough. Listen has scanned over 1 million nearby stars. FAST has been operational for years. The James Webb Space Telescope, fully online since July 2022, has examined the atmospheres of dozens of exoplanets without finding the spectroscopic fingerprints, the industrial pollutants, the megastructure shadows that an active technological civilization would imprint on its star system. Nothing. Not a peep. There are several explanations for this. The most popular is the Great Filter, proposed by economist Robin Hanson at George Mason University in 1996. The idea that something somewhere in the chain from dead matter to galactic civilization kills off almost everyone. Maybe it's behind us. Maybe it's ahead. The dark forest hypothesis is a different kind of answer. It says the silence isn't because nobody's there. It is because everybody who survived learned to shut up. The civilizations that made it past their broadcasting phase did so by recognizing what we have not yet recognized, that announcing your existence in a universe with finite resources and unknown neighbors is the cosmic equivalent of standing up in a foxhole and lighting a cigarette. The ones who did not recognize it are not silent because they're meditating. They're silent because they're gone. If this hypothesis is correct, every civilization that survives long enough to observe the galaxy reaches the same conclusion. Hide. Listen. Never broadcast. The galaxy isn't empty. It is full of careful, listening, terrified intelligences, each one assuming the others are predators, because the alternative assumption is fatal and unverifiable. And we, in our cheerful technological adolescence, have spent the last 100 years lighting flares. You started this with a picture of contact as humanity's greatest possible moment. Now you understand it might be its last. The shift is not that aliens are evil. It is that the rational structure of any universe, with scarcity and unknowable neighbours, selects for silence. The friendly ones got eaten. The smart ones learned that the only winning move was to never reveal that they were playing. Here is the devastating summary. In one line, the galaxy isn't quiet because it's empty. It's quiet because the survivors all figured out something we still haven't. The next problem is harder. Even if every government on Earth signed a treaty tomorrow agreeing to stop intentional broadcasts, We cannot unsend what we have already sent. The Arecibo message is still in transit. So is every cosmic call. Whatever decision is being made about us, in some calculation we will never witness, has already begun. So consider this, the next time someone tells you we should keep trying to talk to the stars. In a forest where everyone is listening, the only species that yells is the one that hasn't learned what a forest is yet. If the comfortable lies of futurism have stopped tasting like truth, subscribe. Hype Decay is where the silence between the headlines gets explained.